Today we're going to be learning about stoichiometry, which is really the study of being able to figure out how much stuff you can make with a certain amount of starting material, or figuring out how much starting material you need to make a certain amount of stuff. And in chemistry, we use chemical equations to describe processes where stuff is made. Right? Now, this chemical equation that I'm showing right here is the reaction of nitrogen gas with hydrogen gas to form ammonia. And the chemical equation is balanced. And what that does is it lets us figure out how much of these things are required to make a certain amount of this. For example, for every 1 mole of nitrogen you use up, you're going to use up 3 moles of hydrogen, and that would allow you to produce 2 moles of ammonia. Okay. We use moles to relate these substances because moles represents the amount of pieces we have. The reason we can't just use grams for this chemical equation is because each substance weighs a different amount. So nitrogen, for example, contains 7 protons, 7 neutrons on average, so it would have a mass of 14. Hydrogen, however, only has 1 proton, so it would weigh, an atom of hydrogen would weigh a completely different amount. It would only weigh 1. So we have to convert 2 moles to allow us to compare the amounts of each substance. We can't just use grams. However, we will use grams later on. So a sample question I gave is how many moles of ammonia can be made from 5 moles of N2? So what we're going to do first is write down what we're given. We're given 5 moles of N2. And what we're trying to do is relate that to how much ammonia we can make. So looking at the balanced chemical equation, you always put what you're looking to find on top, or what's wanted on top, and the substance that you're starting with on the bottom. And then we'll look at the balanced chemical equation for the ratio between those two. So you produce 2 moles of ammonia for every 1 mole of N2. So this would mean we could produce 10 moles of ammonia from 5 moles of nitrogen. Now, we don't weigh moles on scales. We can only weigh grams. So if I ask how much this would weigh, first you have to figure out what 1 mole of NH3 or ammonia weighs. Since nitrogen has a mass of 14, and you have 1 of those, nitrogen contributes 14 grams per 1 mole of ammonia. Hydrogen, each hydrogen would contribute 1.00. You have 3 of those in the compound, so that would be 3 grams. So the total mass of 1 mole of ammonia would be 17 grams. So when asking how much this would weigh, we would say 10 moles of ammonia. We would multiply that by the 17 grams per mole. And this would be 170 grams, which is a tangible amount. So again, just to recap, the balanced chemical equation tells us how many moles of each substance are required for the chemical reaction relative to each other. So for every 1 mole of nitrogen, you can react 3 moles of hydrogen to make 2 moles of ammonia. If I ask you how many moles of product can be produced from a certain amount of reactant, you simply use the ratio from the balanced chemical equation. And then when figuring out how much something weighs, to go from moles to grams, you have to figure out what a mole weighs using the periodic table molar masses.